الرحمن الرحيم. Hello everybody, every single persons. This is a video about an exercise that this exercise deals with Taylor expansion, but it is a little bit hard, just a little bit. So the exercise, suppose that f is a function which is differentiable on the closed interval 0, 1, such that f of 0 equal to f of 1, and this is equal to 0. Suppose that f twice is bounded on 0, 1. This means that there exists a constant positive such that the absolute value of the second derivative at x is less than or equal to n for all x in 0, 1 open interval. The question is to prove that the first derivative, so f prime of x, is less than or equal m over 2 for all x in 0, 1. So we need to think and to try about this exercise to finally find a solution, a way to answer this question. For x which is less than or equal 1 and strictly greater than 0, and less than or equal to 1, we can consider f of 0. This is equal to f of x plus minus x. Taylor expansion, we consider x as x0 and minus x as each. So the variable each, we can write this just to understand x0 plus each to be confident about what we are doing next. Using this idea, here we can write f of x0, so this is equal to f of x, which is x0, plus f prime of x0, which is over 1 factorial, times each, which means minus x, plus, with Lagrange, f of, let us say theta 1, which depends on x, over 2 factorial, times x square. Why x square? Actually, this is minus x square, so it is x square. And theta 1 of x can be theta 1 of x, for example, this can be x plus theta 1 of minus x, and theta 1 is between 1 and 0. Parameterization of the interval x and minus x. This is 1. This is the first formula. For the second formula, for the second idea, let x be strictly less than 1 and greater than or equal to 0. In this case, we can consider f of 1. F of 1 is equal to f of x plus 1 minus x, plus 1 minus x. Once again, we can consider this as x0 and 1 minus x as each. So applying Taylor expansion with Lagrange remainder as in the first case, here we will have f of x plus f prime of x over 1 factorial 1 minus x plus f twice of theta 2 of x over 2 factorial times 1 minus x square with this is a constant, the constant which is between the two endpoints. This is the second formula. From the first formula, from this formula, we have f of 1. From this formula, we have f of 1, so we will take 1, f of 0, so we have this is equal to 0, and if we consider, since x can take 1, so we will get f of 0, this is equal to f of 1 plus minus 1, so this is equal to 0, so here we have 0, but from this side we have 0, this is an hypothesis, this is 0 equal f of 1 plus f prime 1 times what? Times minus 1, and f of 1, this is also equal to 0, plus f twice of theta 1 of 1 over 2 factorial times 1 square. This is equal to 0. Don't forget, this is equal to 0. This means what? This means that minus f prime of 1 is equal to f twice of theta 1 of 1 over 2. From what? We can deduce that the absolute value of f prime at 1 is less than, or this is a value, but this is a value, but it is less than or equal to the maximum of the function. So f prime of 1 is less than or equal to m over 2. And we deduce this from this formula. For the second formula, so here what did we prove? We proved that f prime of 1 absolute value is less than or equal to m over 2 from this formula. From this formula, we will prove that f of 0, from this one, we will prove that f of 0 is actually less than or equal to m over 2. Here we have f of 1. We have f of 1. We take x equal to 0. This is equal to 0 by hypothesis. And from this side, this gives f of 0, which is equal also to 0, plus f prime of 0 over 1 factorial times 1 minus 0, so times 1, plus f twice of theta 2 of 0 over 2 times 1 minus 0 square, so times 1. This is equal to 0. This is 0, this is 0. So what we have? We have f prime of 0 plus equal minus f prime of 0 equal to f prime of theta 2 of 0 over 2. Absolute value, they are equal, and this is less than or equal to the maximum, which is m over 2. So we proved that from the first equation, we proved that the absolute value of f prime of 1 is less than or equal to m over 2. And from the second equation, we proved that f prime, absolute value of f prime at 0, is less than or equal to m over 2. Now, let x be strictly less than 1 and strictly greater than 0. And we take the difference between the two equations. If we take the difference between the equation 1 and the equation 2, here we have f of 0, which is equal to 0, minus f of 1, which is equal also to 0. In this case, we have 0. And f of x minus f of x0, this is equal to 0. And f prime minus x minus f prime minus 1 plus x minus x plus x will be constant, and we keep just what? We keep just minus f prime of x for x between 0 and 1. And here we get plus f twice of theta 1 of x over 2 factorial 2 x square minus f twice of theta 2 of x over 2 times 1 minus x square. All this is equal to 0. I think that I need this place. So this function will gives us, from this side we have f prime of x. This is equal to this one. But if we take the absolute value, this will equal to the absolute value of what? Of f twice of theta 1 of x over 2 minus x square minus f twice theta 2 of x over 2 times 1 minus x square, the absolute value, which is less than or equal triangle inequality, the first one plus the second one, which gives us f twice of theta 1 of x over 2 x square plus f twice of theta 2 of x over 2 1 minus x square. This is positive, and we take the absolute value. I think once again that I can clean this formula that we used to deduce this one. This gives us the right to write that this is bounded by m, so we have m over 2 x square plus m over 2 1 minus x square. And this formula is actually equal to m over 2 times x square plus 1 minus x square, which is equal to we have here square, so we have x square minus 2x plus we have 2x square minus 2x plus 1, and here x is less than 1 and greater than 0. We can study this function. We will show that this function, its maximum value for this function is equal to 1, which means this is less than or equal 1 m over 2. Yes, this we can do it easily. We consider the function f of x, which is equal to 2x squared minus 2x plus 1. Domain of definition, we study this on x and 0. The derivative f prime of x, this is equal to 4x minus 2. So this function take 0, 1, x is equal to 1/2. If x is less than 1/2, it is decreasing. If x is greater than 1/2, it is increasing. The first value is equal to 1, and the maximum is equal to 1. It is so easy to prove that the maximum of this function is equal to 1. This finish this video, the solution. Thank you very much for watching. Hope that we will see next time.